Units and Dimensions. Introduction. A few years ago, a NASA spacecraft crashed on Mars, wasting millions of dollars and years of effort. Engineers controlling the flight had become confused about the units in which distances and speeds were being measured. They thought the craft was hundreds of meters from landing when it was much closer, hundreds of feet. In science, it is important to communicate measurements accurately. So we try to use a standard set of units, known as the International System of Units, or SI units. You will be familiar with many of these already. They include meters, kilograms, and seconds, as well as joules, newtons, and so on. It is useful to understand how these units are related to each other. In this lesson, you will learn the 7 international system SI base units and their symbols. Learn how derived units relate to base units. Learn to check the consistency of units within equations. Learn about the dimensions that correspond to the base units. Learn to use dimensional analysis to check the consistency of an equation. Learn to use dimensional analysis to construct equations. SI stands for the French Système International, meaning International System. This system uses 7 basic quantities. All other quantities can be related to these 7. Mass, length, and time are 3 of the quantities which form the basis of the SI system. You should know the units for each of these. Click the box beside mass and below unit name. What is the unit abbreviation for kilogram? Click the box beside mass and below unit abbreviation to check your answer. What are the SI units for length and time and their unit abbreviations? Click the boxes beside length and time and below unit. It is useful to consider how each of these quantities are measured too. What instruments are used to measure mass, length, and time? Click the box. So far, you have considered 3 familiar base units of the SI system: meter, kilogram, and second. Some quantities can be measured in units that are derived from meter, kilogram, and second. Can you think of any? Answer. Example, velocity is measured in meters per second. Other quantities are measured in units derived from other base units. Think about the scientific measurements you have made in your studies. Can you think of any quantities that are not measured in meters, kilograms, and seconds, or some? Answer. Examples, electrical measurements such as current and voltage, and temperature measurements. Click in the bottom left-hand corner of the table to see the 4 remaining SI base quantities. What is the unit for electric current? Click the boxes beside current and below unit name and unit abbreviation to check your answers. You may be less familiar with the SI unit of temperature. Click the boxes beside temperature and below unit name and unit abbreviation. Luminous intensity is not required for STPM syllabus. The Kelvin scale of temperature is based on a scale starting at absolute zero, the lowest possible temperature. Click the remaining boxes to review the entire table of 7 SI base units, their abbreviations, and how they are measured. Each of these units is defined in such a way that scientists all around the world can check that their instruments are correctly calibrated. How well do you think you know the SI base units now? You can test yourself with this snap game. You have to spot the pairs. Click on the circular button when you spot a pair. For example, kilogram and kg are a pair. Why? Answer: kg is the unit abbreviation for kilogram. Time and S are a pair. Why? Answer: S is the SI unit of time. Ammeter and A are a pair. Why? Answer: an ammeter measures in amperes. A. The game begins slowly and then speeds up. A score of 100 is awarded for a correct pair. But beware, 25 is deducted for an incorrect pair. A score of 500 or more is excellent. Now click Start to begin your game. Good luck! Summary. In science, the SI base units alone are insufficient for measuring most quantities. For example, speed and velocity are measured in meters per second, ms-1. ms-1 is called a derived unit because it is derived from two base units. What derived units are used to measure area, volume, and acceleration? Click the boxes below unit to check your answers. If you are unsure of the correct unit for a quantity, then you can work it out using the equation for that quantity. For example, speed is equal to distance s divided by time t, so its units are units for distance m divided by units for time s, that is meters divided by seconds, meters per second. Click the box beside speed, velocity, and below equation. What equations might be used to work out the units for the quantities area, volume, and acceleration? Click the rest of the. Here are 4 more quantities that are measured in derived units. Before you click the table, answer the following questions. Which of the quantities is measured in joules? Answer: energy, work. What unit is used to measure force? Answer: Newton, N. What unit is used to measure power? Answer: watt, W. Now click on the boxes below unit. Notice that all units are related to the SI base units. For example, what is joule in terms of SI base units? Answer: 1 joule equals 1 kilogram meter squared per second per second. What equations relate each of these quantities to simpler quantities? Click the boxes below equation to check your answers. Electrical measurements include the ampere A, the SI base unit of electric current. Before you click the table, answer the following questions. What unit is used to measure charge? Answer: Coulomb, C. What unit is used to measure voltage? Answer: volt, V. Click the boxes below unit. What equation relates charge, current, and time? Use this equation to relate the Coulomb, ampere, and second. Click the box beside charge and below equation to check your answer. What equation relates voltage, charge, and energy? Use this equation to relate the volt, coulomb, and joule. Now relate the volt to base units. This is quite difficult. Click the box beside voltage and below equation. In your studies of physics and other sciences, you will come across many different SI-derived units. Remember, all such units are based on the 7 base units. Equations can be checked by comparing units. Click Play button to see how this can be done. After understanding this, try a similar analysis for the equation v squared equals u squared plus 2as. Hint: unit of displacement S equals m and the figure 2 is a number with no units. What units are shared by all terms in this equation? Answer: meters squared second to the power of negative 2. Look at the equation. V equals ut plus at. Why is this equation unbalanced? Answer: V and at have unit meters per second, but ut has units meter. How well do you think you know derived units? You can test yourself with this snap game. You have to spot the pairs. Click on the circular button when you spot a pair. For example, m squared and pi r squared are a pair, because m squared is a unit of area and pi r squared is an equation used to calculate area. A score of 100 is awarded for a correct pair, but beware, 25 is deducted for an incorrect pair. A score of 500 or more is excellent. Now click Start to begin your game. Good luck! Summary. Here is another way of thinking about quantities. You can think about their dimensions. For example, any mass has the dimension m. It does not matter whether mass is measured in grams, kilograms, or tons. Its dimensions are still mass, m. Similarly, length and time have dimensions L and T. Each quantity that has a base unit in the SI system also has a corresponding dimension. Click the boxes under Dimension to see the dimensions for all quantities in the table. It is easy to get confused when the same letter is used for different things. What is the difference between m, and m? Answer: M stands for meter, a unit. M in italics stands for mass, a quantity, and M stands for dimension of mass. Here, you can explore the dimensions of quantities that are not base quantities in the SI system of units. Click the box beside area and below dimension. Notice area has dimensions L squared. This is because all areas are found by multiplying two lengths together. What do you think the dimensions of volume are? Click the box beside volume and below dimension to check your answer. Click the box beside velocity and below dimension. Notice velocity has dimensions Lt to the power of -1. Why? Answer: because velocity is calculated by dividing distance by time. What are the dimensions of acceleration? Click the box beside acceleration and below dimension to check your answer. Now click the boxes below equation. These equations can be used to work out the dimensions of these quantities. Dimensional analysis can be used to verify equations. Click play button to see how to do this. Now imagine you are taking an exam and you need to calculate the period of a pendulum. You know that the formula is either T equals 2 pi G over L to the power of 0.5 or T equals 2 pi L over G to the power of 0.5, but can't remember which is correct. Use dimensional analysis to determine the correct answer. Hint: dimensions for G are Lt to the power of -2. Remember that numbers have no dimensions. For each of the quantities in the table above, determine its dimension. Click the boxes below equation to help you. Click the boxes below dimension to check your answers. Dimensional analysis allows possible relationships between quantities to be worked out. This is an important use for dimensional analysis. Use a similar approach to find a probable relationship between average pressure P exerted on the walls of a container by a single molecule of gas and m, mass of the molecule, c, speed of the molecule, v, volume of the box. Now the game gets difficult. The rules are the same as before. You have to click the circular button when you spot a pair, but you have to think about quantities, units, and dimensions. For example, M and kg are a pair. Why? Answer: m is the dimension of mass and kg is the symbol for kilogram, the unit of mass. A score of 100 is awarded for a correct pair. But beware, as before, 25 is deducted for an incorrect pair. A score of 500 or more is excellent. Now click Start to begin your game. Good luck. Summary. Every base quantity has an associated dimension. For example, mass m time t. Derived quantities also have dimensions. For example, velocity Lt to the power of -1. You can check an equation by checking that each term has the same dimensions. This is an example of dimensional analysis. You can also use dimensional analysis to deduce possible relationships between quantities.